So in today's lecture, we'll be revisiting some concepts that we did in last lectures, as well as we'll try to learn something new from it. So today we'll be learning about the exploratory data analysis, or in short, EDA. Okay. So what is EDA? EDA is a process in which you try to understand the data. Okay. When you first receive the data, uh, suppose you are receiving some data for the first time. Okay. So first of all, you need to look into the data, no, like what kind of data it is, what kind of column it is, and what does it try to convey to us. Okay. So EDA first focuses on to understanding of the structure of the data and identifying the pattern and the trends and detecting any kind of anomalies or outliers if there. For example, some kind of missing values or some kind of like values uh, that you may think like it's a very low chance of having that value in the column, or it's just like therefore it doesn't make sense. For example, if you take example of suppose you have a record of heights of students who are in, let's say, fourth class. Okay. So suppose, let's say, average height of the fourth class student would be around let's say 100 centimeter. Okay. Not 100, like take it 120. Okay. So suppose in that class there is a one student who has a height of, like, take it as example, 185 centimeter. Okay. Now that alone student is kind of an anomaly or outlier in the entire class. Okay, because average height is 120, so maximum height would can go to, other than that, an outlier student can go to around 125 to 127 at max. Okay, but that student has a height of 185 centimeter, so that is a outlier in the entire data set. Okay, so EDA used to deal with such kind of outlier datas. Okay, and what they are and what kind of like pattern and trends there are. For example, if I said that there is a average height of 120 centimeter. Okay, so that average height, how did we find the average height? We use some kind of like process from which we can calculate the average height, so that we can like signify the data of the entire class using a single figure or single metric. Okay, so that's where EDA comes, exploratory data analysis. Okay, it's basically your discovery. It's a very first and very important very important process, because if you don't do EDA right, the data will that will go forward, it will be useless. And if the data that will go ahead is useless, the model that you will train the data upon will give you useless outputs. Okay, so EDA is a very first and one of the many very most important uh, processes in the field of data analytics. Okay, so why EDA is important? Okay, as I was saying earlier, like helps us, it like identifies the missing values, outliers, data quality to issues. Because if the data is not like up to the par, your end product will also will not be not be the up to par product. Okay, and you may have to face some losses, or your findings may not be as good as you think. Okay, so EDA like helps us in asking right questions, like what kind of insight that can I draw from this data? Like if there's some missing values in the data, so how can I fill it? Or should I even need them? Or is there a column that is of no use to me? Or how can I like find the outliers? Or what kind of data, like what data is trying to convey to us? Okay. For example, if you say, I give you uh, some kind of medical record. Okay. Let's say I will give you some kind of medical data, And I will ask you, look, here this is a medical data of various patients that come to the hospital. Okay. And now I will ask you, like, okay, how much, according to this data, how much revenue growth of the hospital should be? Okay. So the question, is it in entirety? It's wrong according to the data, because you have the medical kind of data where you can like gain insights from the medical, like what kind of common diseases or common heart patterns or common uh, health metrics that the patients have which come to the hospital, not like how much money they are paying. Okay. So always try to ask the right questions when it comes to data. Okay. Like what kind of data it is, what kind of questions, what kind of insights can I frame out of this data. Okay. You look into data and just outline five rough uh, insights. Like I'm just looking at data, I know these are the column names. So, and this is some kind of data. What other rough estimates that can I draw from it? Okay, rough estimate. They can be changed in a very next process, but what kind of rough estimate I am getting from this? Okay. So what EDA is does is like it guides our feature engineering and model selection. Okay, so written in the slide. Feature engineering means like uh is basically study on the data points or columns or data to make it more uh, to make the data more let's say make a data in good in quality. Okay, so that if the data is in good quality, the model you will train on it will also be in the good quality. Okay, there's a like famous saying in the right in the field of data science altogether, like garbage in garbage out. If you put the garbage in the model, it will only give you the garbage. Okay, so you have to first like increase the quality of the data and remove the useless things out of it. Okay. Okay. So types of EDA. Okay. There are like as you can see, all the data types covered in three types of data analysis. Okay. One, you have univariate analysis where you analyze single variable, and the example metrics for that is mean, median, and mode. Okay. As I was saying in the very first slide, I took example of heights of the students in the class, right? So heights of the students is like I can like just calculate the take the average of the heights of the student. Here only one column is there which is called heights or single variable, if you may, which can be calculated using mean, median, or any kind of distribution. Okay, distribution means variance or standard deviation. Okay, if even if like if you're from the science or your commerce field, you must have learned about these distribution stats because they come in every field. Okay. And second type is bivariate analysis, in which there are two variables. Okay. In now, uh, instead of heights of the students, I will take heights as well as weight of the student. Okay. So from these variable, how can I like analyze them? For that, we can use correlation. Uh, we have this correlation word come again and again even in the past lectures. So I guess you would already know about what is correlation. It is basically a process of how to calculate relationship between variables. Like if one variable increases, what is the behavior of the other variable? Okay. And scatter plots. Scatter plots are basically a visual metrics like visualization where you can see like on what height, what should be the weight of the student. Okay. It's basically a visual representation of the variable. And another is multivariate in analysis. Okay, it means interaction between multiple variables. Now it is multivariate analysis is closer to the real world data. Okay, in real world you will have mm, uh, many variables. Like let's say 20 to 30 would be like just minimum amount of variables you will have. So from that, you will have to find out like what are the variables that are uh, useful. Okay, and how will you do that? For example, you will use heat maps or pair plots. Heat maps you have already know, it's basically visualization of the correlation of the variables. Okay, and pair plots is also is a visualization in which distribution is shown according to the distribution relationship shown between the columns. Okay, we all did these things in the past lectures. Okay, so you must be familiar with them right now. If you revisited lectures or did your assignments correctly, you would have known about all of these things. Okay. Mm, yeah, am I audible? Let me check my mic.
Yes, sir, you are audible.
Okay, okay. So these are the types of EDA. Basically, these three cover entire EDA, entire EDA. Okay. So key steps in EDA. Okay. First of all, you need to understand the data set shape and structure. Like shape and structure basically means like how many columns are in their data and how many records are in their data. Basically, rows and columns. Okay. Because what happens, like sometimes uh, data may not be uh, in an amount that can be used to train a model or take out any insights from that. Okay, so basically you should like work upon at least a data set that has around minimum 10 columns and 1000 records. Okay, 1000 rows. Okay, so that is a good amount, minimum amount of data that can be used to gain insights from. Okay, let's check the data types and summary statistics. Okay, data types means like what kind of data it is. Okay, you have many types of data types. For example, you have categorical data type in which where all your non-numerical data types come. For example, you have a data, for example, in which their words are used. Okay, like for example, I will take a column called blood type. Okay, in which you won't have like 1, 2, 3, 4, 5, 6. You will have A positive, B, O negative, A negative, and all that types. So these are categorical data types. And you have numerical data types where you will have numbers or integers or floats, even maybe. Okay. And summary statistics means basically like what is the mean, uh, what is the mean numerical value in the numerical column sets, or what is the like what are the unique categories in the categorical data set. Okay. And you can also have like date time type of data type. You saw that in the time series analysis lecture. Okay, and handle missing values. What happens in the real world data is that sometimes some column values in the records are missing. Okay, data is not perfect. You have to make it perfect. Okay, so there's a many things like how would you deal with some missing values. Either you will delete the entire record which contains the missing values. Okay, but that is not advisable because sometimes what happens like you have like if you have 100 records and 10 of them have a missing value, so it's not as advisable like you can like delete 10% of our data just because it doesn't have a single value. So what do we do is like fill it with the mean or median of the data. Okay, I will show you that in the code. Or if the data doesn't have missing value, I will just show you like how do we fill the median missing values. Okay, and detecting outliers. Okay, For detecting outliers, if you visited previous lecture, there is a visualization called box plot. Okay, so box plot is very useful in detecting outliers. Okay, and what is if you don't remember, like what is outliers? Outliers are basically like a value that that is very different from the rest of the records. For example, suppose mm, what example should I take? Let's just say uh, you have a ball of fruits. Okay, you have a huge ball and there's a different kind of fruits in there. Okay, now if I put a potato in there, in that ball with fruits, so potato would be outlier because potato is not a fruit, it's a vegetable. Okay, so potato in that case is outlier. Okay, so that's how we detect outliers. For example, if you have some kind of data and the maximum range of the entire data is, let's say, 25, but one value or two values in the data set that has a value, let's say, 100 or 350 or 500, so that is a outlier. Okay, and what do we do with outliers is sometimes we let them be because some kind of, if you want to test some kind of edge cases, like somehow one day there come a unique data, and how can the machine handle that? So for that we try to take the outlier, use the outliers, but most of the time we try to like remove the outliers from the data. Okay, and visualize distribution. In the when we were learning about the visualizations, you learned about many visualizations, for example, heat map, bar graph, or box plot, histogram, many other visualizations. So in that visualizations, basically what you do is you present your insight in a pictorial form. Okay, for example, you have some kind of data. So for example, let's go back to the example of fruits in the bowl. Okay, so you have four types of fruits there. Okay, let's just say apple, orange, banana, and let's just say three. Okay, apple, orange, and banana. Okay, now I would ask you, like, how many apples are there, how many oranges are there, and how many bananas are there. Okay, so for that, if you I ask, like, I don't want to know the numbers, I want to you to show me by some kind of visualization. Okay, so what could be the best visualization to represent it? Okay, like you some would say like you can also use pie chart or bar. Best would be bar chart, but you have to know about the visualizations to know about like what kind of best visualization out there would be able to represent data. So in that case, a bar chart would be best visualization. You create a bar chart out of that data and show it to me. Okay, so that's is one of the steps in EDA. Okay, visualization distributions. Visualize distribution. Like how can you show the data numerical or data set in a pictorial form? Okay, and the last step is study relationships between variables that we did in the previous lectures in a form of heat map and correlation. Okay, like if I put another banana in the ball, would that and would that make any effect on the number of apples or oranges? No, it wouldn't. Only number of bananas will increase. Okay, so in this case, like there's no relationship between the variables, or variables are not affected in any way from one another. Okay, so that's what we do also in EDA, like study the relationship between variables. Okay, this think of it, this lecture as a culmination of various things that you learned in the previous lectures. Okay, you have visualizations you learned about, you have EDA, you have going forward, you will see many functions that you learned about in the previous lecture. Okay, so let's go to the code. And here I have a RCSV, which is basically medical records of people. This is a sample data. You can work on any kind of data. Uh, Go to, if you want to work any kind of, go to Kaggle. Okay, this is your machine learning data science community. Go to this side and you can search for any kind of data sets here. Just you have to type data sets and you will get a plethora of data sets from here. Okay, so let's go to the code. This is PD. Okay, and yeah, import matplotlib or pyplot splt. We will also import Seaborn as SNS. Okay, um, and let's now import our data pd dot p dot csv, and we will use tf dot head. Okay, now I received this kind of data, or you receive this kind of data. Okay, you see, like df.head is, you should always like use df.head, because what it does is it displays first 5 records of the data set. Okay, so that now we have some kind of understanding, like what can we expect from this data set. Okay, now let's just say I want to know uh, df dot let's say chest pain type. Okay, it's a third column, this one. Okay, ATA, NAP, and ATA again. I want to know, not df dot, I should write like this. Okay, and you should also write like this. Chest pain type. Okay, dot. I want to know what is, like, I am seeing ATA, NAP, ATA, ASY, NAP, but it's only 5 records. Okay, I want to know what are the unique categories that in chest pain type. Okay, for that I will use dot unique function here. Okay, and when I run it, you can see now it will, in the entire data set, what are the uh, unique values that are used in this data set. Okay, I think there's some kind of error, because since ATA is not in it. Yeah, ATA is ATA, NAP. Okay, yes, I, yeah, it's okay, okay. So these are the 4 values. Here we have ATA, ASY, and NAP. Okay, yeah, I got confused. We are only saying 2 values here. So these are the 4 values you will find, and these are the only 4 values. Okay, you won't find any other value other than this in this chest pain type record. Okay, so that is also helpful to know that when you try to train the model, there's there are types of things, like for example, you encode this data. What happens is this data will be converted into numerical type. Okay, so for that we need to know like how many unique values are there in this data, so that we are able to categorize this data variable or column if you may. Okay, so let's not deviate. Go back. Let's go back to lecture, like what kind of things that we have to follow. Okay, so df.head we did. Now df.info and df.describe. Okay, df.info gives about to the data types and missing values. Okay, and describe gives you the statistical summary. We did both of these functions in the statistical lecture we did in way back. Okay, let's refresh our knowledge on that. Okay, so if I go and use df.info, okay, so it will give me like pandas core frame, data frame, it's of data frame, data type. It has 918 entries. Okay, and it will give you information about the uh, data columns. Okay, like you have these columns: age, sex, chest pain type, resting BP, cholesterol, fasting BS, resting ECG, max HR, and many other. And non-null count. Non-null count means like how many values like, are there in the data set which are filled, which means these does not contain any null type values. Null type values means empty values. So you can see in this entire data set, there's no empty values. Okay, it means all this data is good, and we can like skip the step where we put in the missing values. Okay, and let's just say even if there is a missing values. Okay, so how can we uh how can we uh find out if there's a missing values or not? Okay, there it is one way. There's another way called df dot is null dot sum. Okay, it will give you uh let me write in a comment. It will give you number of empty slash na slash null values. It means either empty, it like some say empty values, some say na values, some say null values. Okay, you can use any terminology of your choice. It will give you values in a particular in all the variables slash columns. Okay, so as you can see in that data set, you have zero null values, zero empty values. So where the step where we fill the empty values with mean or median, we can skip that. Okay, since you should know like if even if we have, what should we use there. Okay, so let me put a mark down here. Okay, how to fill empty values. Okay, what you will do is use df dot fill na. There's a function called fill na. Here you will use df dot mean. Okay, now this function is here. You should use it column wise. Okay, I am using taking example of chest pin type, but after using this or using df.info, you will find if you look, you will look at the range index. Okay, it will show amount of records here. Okay, data columns like amount of columns here. If you find like non-null values is less than number of entries, it means that there are some kind of empty values. Okay. Or another way is simpler way. You will use co this small line df dot is null dot sum, and you will get this kind of data frame here. And in this you can see 0 0 0. If the data contains some empty values, you will find the number of those empty values per column. Okay, suppose age we have 5, chest pain type we have 7. Okay, so in that case what you will do, take the individual column, use dot fill na function, then either fill it with mean. Okay, chest pain type. Okay, either fill it with mean. Okay, either fill it with median, or either fill it with mode. Okay, why mode? Because sometimes what happens, chest pain type is a categorical uh, variable. Okay, you can't calculate the mean or median out of this. Okay, mean and median basically calculates from the numerical column data sets. Okay, if I go around this and try to calculate df dot chest pain type dot mode. Okay, like all this. Okay, it will give you ASY. What is ASY? ASY is the most recurring values in this column. Okay. Since you get in a data frame, use either one, I guess, index, or let's say 0. Yeah, you will get a string value like this. You have to replace the empty values using this. Okay. Use this when dealing with empty values in categorical data. Okay. Uh, okay, like note that thing if you have pen, or make a mental note out of it. Like use mode when you have categorical type of data. Use mean or median. Okay, I will go like which is the better choice. But use mean and median when it comes to numerical type of data. Okay. Now, why mean or median? Okay. Sometimes we use mean. Okay, let me take a numerical type here. Age. Okay. Age dot mean. And there's one more thing here called in place is equals to true. Yeah, you should use capital 2. Okay. Which means it will permanently replace the value. If you don't use this, what will happen? It will put the values when you rerun the code, entire code. You will still get those empty values. What it will do? It will be permanently put the mean or median value there. Okay. Now, why I'm saying mean and median? Okay, so let's just try to run this code first. Okay, np.float is 53.51. Okay, if I use 0 here, what will happen? Not 0, index is not there. Uh, okay, it's a scalar value, so NP float is fine. Okay, it will only put 53.51. Okay, now there are two choices, either put mean and median. Okay, let me write this here also. Median 54.0. Okay, mean I have 53.51, 54.0. Okay, so what should I use? Look, according to me, I may be wrong in the future, or there's someone who knows better than me, know may say I'm wrong, but you should use median to fill empty values when it comes to numerical data set. Okay, why? Because median is, or mean is susceptible. I do not remember this spelling of susceptible. Let me check. Susceptible, Tible. Hmm. Yeah, I was right. Okay, to outliers. Okay, how do you calculate the mean or average of the values? Okay, what you do is that you will take all the values, add them, and divide them by the number of values that are in the data. Okay, which means you will also take the outlier value which is inside the data and calculate the mean out of it. So your mean value is can be changed according to that outlier value. Okay, if I take the mean of five numbers, 1, 2, 3, 4, 5, or 1, 2, 3, 4, and 10. Okay, so the biggest value can pull the average to its size. Oh, sorry, its side. Okay, so what will happen is that you will sometimes you will get the data that is somewhat wrong, or you may not get insight that you were looking for. Or when you try to train the model sometimes give you wrong output, and you will like not never like you will have to like do a lot of head hunting, like why am I getting this error, or my model is not performing as per the standards. Okay, whereas median is not susceptible to outliers. So it's the best practice whenever you try to fill the empty values, use median. Okay, since in this data we don't need to fill the empty value, I just told you like if you get empty value in the future, what you need to do. Okay, and the third thing that was df dot describe. Df dot describe will give you statistical summary. Okay, like what is the count, what is mean, standard deviation, interquartile range, like 25% of the value, 50% or 75% of the value, maximum value. So notice that you have only numerical values here. Okay, you do not have like chest pain type or sex or exercise enigma. Okay, it will automatically only work on uh, numerical values. Okay, if you want these kind of mean values, it's okay. But according, if you just how want to know like what are the empty values, what kind of records are there, it would be better you use info. Okay, let's move to the next. Okay, missing values. I told you already about the missing values, how to handle missing values, and how to use outliers. Okay, for outliers, you need to use box plots or IQR methods. IQR method means interquartile range. Okay, these are the interquartile range 25%, 50%, 75%. These are called interquartile range. Okay, it's like advanced concept. and it won't be able to covered in this time, the time we have left. So you use box plots. Okay, you already know how to use box plot, right? Because you learned about them in the visualization lecture. Okay, and we move forward. Okay, so what are the common plots in EDA? You have histogram. You find out the distribution, like how the data is distributed among the points. Box plot, you have need to detect outliers. Scatter plot helps you in relationship, and heat map. Heat map uh, helps in the correlation of the data. Okay, so let's PL. You first of all let's use scatter plot. Scatter plot. PLT dot scatter. Okay, I'm taking df dot age. This will be my x-axis. Okay, the first column I take will be x-axis. Df dot, let's say, heart. What was the, yeah, last column? Heart disease. Okay, plt dot show age. Okay, a is not capital. So this kind of distribution we are getting. Heart disease only has zero, either one. Okay, so let me use another data. Let's say resting BP. Okay, so you can see it's basically like x-axis we have age. Let me put labels. Okay, plt dot x label age, plt dot y label resting BP. Okay, what happened? Why showing two figures? Okay, I have to use plt dot show after. Yeah, keep that in mind. You have to first use label, then use plt dot show. Otherwise, it will show it like this. Yeah. So we have this kind of distribution between age and resting blood pressure. Okay, so as you can see, like around, if you are below age 40, you have this kind of blood pressure around 125, 200. Okay, so this is all like calculate the relationship between the objects, sorry, variables. And if I use tf dot, if I use, let me create another data frame for heat map, because it will only take uh, numerical values. Okay, let me just copy paste. It's not age comma resting BP, not resting BP is okay. And I will take which one, cholesterol fasting BS. Let's just say 4. Okay, for timing constraint, let's just say 4. Okay, fasting BS. Okay, cholesterol not in index by CHOL. If there is there spelling mistake, let me copy it from here. Now I will uh, plt dot heat map df1 df1 dot core co which is basically used to calculate the correlation between the variables. Okay, and note is equals to true. Has no attribute heat map, then okay, SNS has heat map. Sorry, SNS. Yeah, this is the heat visualization representation that used to calculate the relationship between correlation between the variables. You know about correlation, it range from -1 to 1, 0 to 1 means positive, 0 to minus means negative. Okay, I will only take four. Usually, you take the all the numerical columns and then try to create a heat map out of it. Okay, heat map does not take categorical values, so keep that in mind. Okay, so box plot is also there. Let me just create a box plot. SNS dot, yeah, yeah, box plot tf dot age. Okay, let's see. Again, I have to use a capital. Yeah, so it doesn't. Uh, is there any like I have to put something in y also? Data source by form, x column name, vector, none, y column name. Let's try. Okay. Okay, yeah, it only takes one. Okay, so it shows you the outlier. Since we don't have any outline the age, let's just take resting BP. I'm sure it would have an outlier values. Yeah, see this circle here, you see these circles and small circles. These are outlier values. Okay, so you can use box plot to see the what kind of outlier values does it have. Okay, or you can search on the net on your own if you like know like is there any code without any visualization. For that we can find out the outliers. Uh, and there's your small homework for this lecture, other than assignment, of course. Okay, so like patterns and anomalies, like you have to like find out the patterns in that data, like trends, what kind of trends. If you have some kind of time series or sales data, you will have to calculate the trends over time, like during the time of sales, what kind of trends were or what kind of trends are we seeing in the future. Correlation the variables between variables like we did in heat map. Okay, what is a group wise behavior, like what are the particular columns are behaving that when we try to plot them against each other. Okay, and what are the anomalies? Anomalies are the extreme values, unexpected spikes or drops. As I said, like uh, these you can see these are outliers, unexpected spikes. Okay, either you can drop them or try to fill them with the mean values. Okay, mean or median values. Okay, or data inconsistencies. These are also can be classified as data inconsistencies, or you have some kind of empty values or extreme high values, then the values that are way greater than average. So these come in data inconsistencies. Okay, you have to remove these kind of anomalies from the data. Okay, always ask the question in your mind that does it makes business sense or does it make sense when I try to present the data. Okay. Or you can think of it like, uh, if there is no counter question to that insight, like how come it is true or how come other thing is not true, then it's okay. You are on the right track. Okay. So, summary for this lecture, like, what are the key takeaways from this lecture? Like, ED helps us understanding data before modeling. It is like ED is a starting point of the data analytics. Like, you have to like understand the data, visualize data, create patterns out of the data, try to understand what data is trying to convey. Okay. Like, and second point, we combine statistics with visualization. As I showed you earlier, you have to visualize the data, use some kind of statistics such as mean, median, mode, or correlation is also form of statistics, and pattern guides insights anomalies raise question. Okay, which means patterns, if you find out like there's some kind of pattern being followed here, so that is insights. Okay, and other than that, you have outliers, empty values. These are anomalies, these raise questions. Okay, so either you will gain a smooth pattern insight or gain some kind of anomalies. What happens, some kind of data in some types of data, like, you look into data, you find some anomalies. For example, you have uh, account information of some company. Okay, what accountants does is they see the data. If they find patterns, okay, fine. And if they find some kind of anomalies, like where is the money going, okay, why are not the amount invested and amount gained, there's no not kind of relationship, like where did the money lost. Okay, these are also kind of anomalies that you try to find in the data. Okay, that depends totally on the use case. Okay, so either you will get a pattern, which is mostly in the case of machine learnings and data science field, or anomalies basically, which is in, or you could say, cyber security or accountancy, or if you know about audits, like periodic audits, company check its itself, check its data, like, is there some kind of anomalies in our business practices. Okay, so these are kind of also anomalies which comes in, like cyber security or business studies and all that. Okay, so go through this lecture again, because I think it was like one of the most heavy lectures, and try to uh, work on some kind of your data. Go to Kaggle, look any kind, uh, practice on any kind of data. Okay, look like what kind of data is there. Follow all the steps given that are given in the lecture, and try to find your own insights. Okay, and that is your assignment for this lecture. Like, you have to perform EDA on the data, load data set, check missing values if there are any, visualize distributions, create heat maps, box plots for outliers, or scatter plots or line plots for the data or relationship between the columns. Okay, and try to find some patterns or anomalies. Okay, write any three key insights. You just have to write them, like what kind of insight are you getting from the data. For example, if you have some kind of sales data, you will have there, okay, the sales dipped from 2022 because there was COVID. So that's why the sales which were going up in the visualization suddenly crashed down. Okay, so this can be counted as insight. Or after COVID, when the market picked up, the sales automatically went up. Or why it didn't went up, because the product uh, has been out of fashion, out of needs, or people have outgrown the product. Okay, so these kind of create any three these kinds of insights, and submit your assignment in the link in the assignment. Okay, so that's the end of the lecture. If you have any doubts, you can ask right now, or we can end this lecture.